Hi there. This is a video over a couple questions about the quadratic functions and stuff like that. This was submitted to me, and so I want to just give an example of how somebody would submit a question and how I would go about answering that. So the first question is, can a quadratic equation have only one solution? The answer to that question is yes. So how I think about it, you've got three options. A quadratic equation has two solutions if the parabola intersects the x-axis at two different points. Okay, you can have one solution if a quadratic function has its vertex at the that is on the x-axis. Okay, so that's one solution. And then we have zero solutions when you have a quadratic function that just does not intersect the x-axis. Okay, so that's the idea. We are concerned with these points as to where they cross the x-axis. So what I want to do is talk a little bit about how you would come up with an example for a quadratic equation with only one solution. And this comes from a perfect square trinomial. Okay, and a perfect square trinomial, those are just going to have one solution. So what we want to do, and how you get a perfect square trinomial, let's look at the factored version of something. Usually what you have is, let's think of an example like, say, x plus 3, that quantity squared. All right. What I want to do is multiply this out. And, what this means is I have x plus 3 times x plus 3. And so if I multiply this out, I'm going to get y equals x squared plus 3x plus 3x, and then plus 9, okay? And so from here, x squared plus 6x plus 9, these two things mean the same thing, all right? This is in standard form, okay? And this is in factored form, okay? And so what you want to look at is this is just a generic example of a solution that would cross the x-axis once, okay, where your vertex is at that point. And how you do this, you can do this by completing the square, or you can use Pythagorean theorem. I would just think of factoring this. If you're looking to factor this quadratic and solve this by factoring, what you're going to do is you're going to take x squared plus 6x plus 9 and set that equal to 0. All right, and if I were to solve this equation, I would factor it first. Two numbers that multiply to 9 and add to 6 is going to be 3 and 3, okay? And so because this repeats, because you have the same factor twice, you can kind of get more into this, but it's going to bounce off the x-axis at that point. You'll probably learn more about that, but when the factor happens more than once, that's what's going to happen. If the factor happens only once, usually it's only going to cross the x-axis. And so from there, you set each of your factors equal to 0 when you solve a quadratic by factoring. And so here you get x is equal to negative 3, x is equal to negative 3. Because this is the same thing, you have one solution, and that solution is x is equal to negative 3 from that equation. So you can really choose whatever you want. Any other perfect square trinomial, if you had y equals, say, x minus 1 quantity squared, anything where you've got that quantity squared and no other number to the right of it, this is going to be good. So not sure if you need that in factored form or in standard form, but that's how you get one solution, okay? Let's just think of one where you don't have one solution. And one of my favorite quadratic equations is x squared plus 7x plus 12. And yes, I have favorite quadratic equations. So I'm going to factor this, set this equal to 0. This is going to factor to x plus 3 times x plus 4. All right, set each of those factors equal to 0, and you get two solutions out of that. And so that's an example of something where you would get two solutions. All right, and so even though you're getting two solutions out of that, these are two unique numbers. Versus here, where while yes, you did have two solutions, but it's the same number, so therefore it's just one number, one solution, and that's kind of how you look at that. Looking at the second question that you asked, the second question is which methods can be used to solve any quadratic equation. I answered completing the square and the quadratic equation. Is that right? Yes, you are correct. You actually have three methods. And so, the first one you always check is you always check to factor. And that's what I just did in that previous, in those examples I used by factoring. So three methods to solve quadratics is by factoring. The other is completing the square. And finally, you can use the quadratic formula. The interesting thing about completing the square and the quadratic formula is that these things are essentially the same thing, and they will always work, okay, no matter what. If the factoring method does not always work. So factoring method only if a quadratic is factorable, is that when that works. So is factorable. So not every quadratic equation is factorable, but you can always complete the square and always use the quadratic formula because they will always work. And so you got to be careful, how you read this. So if it says which methods can be used to solve a quadratic equation, you would want to put all three. That you can factor it, you can use completing the square and quadratic formula. But because this is asking to solve any quadratic equation, it's strictly only these two. So hopefully that helps. Let me know if you have any other questions. Thanks. Bye.